welcome to round two, our second Future Talks panel here at Emerson's booth at Hannover Messe 2025 this morning, and we're going to be exploring one of the most transformative topics in the industry, which is, of course, the power of AI in industrial automation. The panel we just had actually set us up really nicely for that, because that was sort of the end of the discussion where they pointed out also a lot of the challenges being faced by customers, challenges being faced at the system design level, and also from a data collection point and collaboration, the necessity of collaboration amongst all players along the value chains. So AI actively shaping the way manufacturing and production are transforming. And to discuss these topics in detail, I'm delighted to introduce two of Emerson's eminent AI experts. We've got Amit Patel over here on my far left, who is Director Intelligent Automation. He's based in New Jersey at headquarters. Welcome, Amit, and great to see you again.
Thank you for having me, Corinne.
And Arvin Rora, who is Director Engineering Industrial at Emerson, and very glad to have you on this panel as well this year.
Thank
Arvin,
you.
welcome to both of you. So I think I'd like to start with a big picture question like we did on the last panel, which is, and I'll start with you, Amit, just sort of where do we stand today in terms of actually companies adopting AI tools in manufacturing and production? Are they already well established? Would you say that we've been talking about this for 3 years now? So 3 years on from where we started the beginning, when floor to cloud was something quite new. What's the state of play today?
Yeah, absolutely. Great question. I mean, I don't think anyone is a stranger to the topic of AI and machine learning, right? We use it in our daily lives. Most folks and customers that we talk to have some form of AI program in place. Actually, a recent survey of about 1,800 manufacturers show about 89% of them have some plan to invest AI, and about 70% of them already have some implementation underway. AI, it's making its way across many areas of manufacturing, from design to processing to maintaining. And some of the results that you see are quite significant, right? If we look at it from, of course, being more competitive and more profitable. Are you creating more productivity in your workforce? Are you filling the automation gap or skills gap? There's a lot of areas that AI is impacting in the industry today. And in terms of how we think about how well they're established, well, you'll hear it from myself and Arvin a few times in this talk. It's really important that we focus on the use case, because I think what I see as being successful at adopting AI, scaling it, and having some form of established program is really going to be dependent on the use case.
Dependent on the use case, okay. And so from an engineering industrial point of view, Arvin, what's your vision of the state of play and where we're going with it?
Yeah, I couldn't agree more with Amit on what he's saying. So I'm roughly working on real-world AI use cases since 10 years, and I saw, let's say, 50 of them going productive. So from my point of view, there's already
50 out of how many?
Well, 50 I've collaborated on
that you've collaborated on, okay,
with my
and all have
teams
gone
and
forward.
customers.
Yeah.
But as Amit said, those were very specific engineered use cases. It's not that we just have thrown AI on an arbitrary problem and it just worked. And well, certainly since generative AI entered the stage, it's only 3 years ago actually, or let's 3 to 4 years, awareness raised across organization on the topic of AI. But still, companies are they do
reluctant?
Well, they have different progress, I'd say.
Right. Different levels of progress.
Yes, I'd state, let's say, 3 major critical factors for that. So still companies must be willing to explore and evaluate the potential value of AI, since this is very dependent on the context, on the tasks, on the information richness of the data. They really need to translate business and operational objectives into measurable metrics for AI. And last but not least, I think this actually is the most important thing. You really need to seamlessly integrate AI with processes, systems, devices, and especially operational workflows. Because I mean, end users don't care about AI. They may be fascinated, but if they don't have tangible added value in their day-to-day work, they simply won't
They
use
don't
it.
see the point and
Yes.
don't want to use it. It really does come down to sort of demonstrating that business case, and perhaps specific examples would be a good idea to look at how you can do that. I mean, obviously AI is making a huge impact in things like predictive maintenance we talked about already, process optimization. There are things also like fluid technology, I think was something we mentioned in the last
Sure.
panel. So let's focus on that for a second. What sort of are the specific examples that you would bring forth, Ahmed, to demonstrate the advantages of AI in these many applications that we're talking about?
Yeah, I mean, look, AI and the models that are generated are really good at, let's say, two things. Of course, there's many other things that they're great at, but they're really good at identifying patterns and building really complex relationships with different data sets, right? And you mentioned predictive maintenance. Quality is another example, right? So if you really look at what Arvin was mentioning around use cases, and business leaders and manufacturers have to be quite pragmatic with this topic, because the hype is real. You don't have to walk even one booth away from here to see some form of AI or discussion around AI. And I think the important thing is you have to be pragmatic with these use cases, and quality is one big example, where you can look at end-of-line packaging, for example, apply some vision sensors, compute that information, and now you could start to see defects according to a reference or a gold standard. And therefore, you don't need somebody sitting there all day doing some quality type of analysis, right? They can be free to do another task, perhaps more important task. And of course, the predictive maintenance topic is quite significant. We see that in our applications today. I would say your comment around the fluid power topic is quite important, because within Emerson today, this is a key area we're looking at. And one example I give you is around the topic of sustainability and energy efficiency. If you look at compressed air, for example, compressed air is inherent in many manufacturing facilities today. And sort of the overall, let's say, statistic is that about 30% of the plant's energy goes towards the generation of compressed air. Okay, well, about 15 to 50% of that air that's generated goes to waste. And there's a lot of reasons why that happens. That's because you have improper sizing in your pneumatic circuit. It could be because your machine is not producing anything and it stays idle, and therefore air is just running. You have leaks throughout your system. When you walk in a plant and you hear hissing, that's air being exhausted. So there's inherent inefficiencies with air today. And one of the examples, and Arvin will go into perhaps a little bit more technical detail, is one of the first AI solutions that we're bringing to the industry is our leakage locator, which is a solution that can pinpoint and detect air leaks right at the source. So this is one great example of how we can provide our customers with better tools, better prescribed information around tackling a topic like compressed air, which is across manufacturing, and we all realize that it's inefficient today.
Thanks very much, Ahmed.
Sure.
And Arvin, I would just ask you to sort of enlighten us with a couple of case studies to make this even more concrete.
Yes, sir. Well, I'll try to go a little bit more into detail without being too technical.
Everybody's still awake here in the front row, so it's okay. It's okay.
Well, it's not a nerd talk, I hope. Well, actually, basic automation is around for quite a while, and of course you have intelligent algorithms based on heuristics, but machine learning has the ability to really detect patterns and vast amounts of data and deliver and derive new insights from that. And as Amit mentioned, so one of the major solutions we are focusing on is the so-called leakage locator. Means that we already have proven not only on our artificial or, well, let's say easy data, but on real-world data and a lot of lab experiments, that we not only can detect leakages, but really locate them down to the valve level. We do that by actually using very fine-grained and dynamic patterns, correlations between sensor and control information. And well, humans couldn't detect that, by the way. So we're really looking on effects on the millisecond level, but it works. And it's important. This is already applied under productive conditions. And by this, we are not only avoiding high efforts, but because typically searching for leakages is very, you have a very high effort and very expensive equipment, but we do that continuously. So we are able to detect leakages and give early insights. I think that's the most important thing about that.
One of the topics that came up on the last panel was, of course, this question of making sure that of model-based development. And I mean, obviously, with new technology come a lot of new challenges, as you've already hinted at. What are the key challenges, Amit, that companies are facing when selecting how to deploy an AI model?
Yeah, so I think, for me and some of the experience we have, even internally within our organization, and as we work with customers on this topic, I kind of boil it down into three, let's say, areas: vision, governance, and people. And let's start with vision, for example. I think the most important thing is for customers to really understand what is your factory or machine of the future. What is the guiding principle that you're going to set on this topic? And then if you want to go a little bit deeper in that layer, what is the type of technology infrastructure you're going to build? All the way from the data that's collected, how it's contextualized, whether it's computed at the factory floor, are you sending it to the cloud? And then who and how are you going to interpret this information, and how are you going to package this to be as spoon-fed as possible? Arvind will talk a little bit about this and has mentioned it before, is that, to be successful, you really need to deliver the sort of ease of use of these AI solutions. That's really where you get scale and adoption. Governance is the second topic I said. Governance is important for two reasons, right? Leaders and plant managers down to your technicians and operators all have to be aligned around what are the policies that you're going to be putting in place around AI from a security standpoint, in terms of the types of data that you want to capture and unlock. And then the last piece is around people and talent, right? We all know today it's not so easy to find the right skills, and even if we do, it's not cheap, and they're limited. And this is an evolving, fast-paced industry. And one of the things that is a big challenge is around people. Finding, let's say, the domain experts, but also finding people who are involved in more of the data applications as well, whether it's around data science, prompt engineers, for example, the right IT folks to help connect the dots. I would say these are the three major areas. And successful companies don't do this in a monolithic way. They work and partner with suppliers like Emerson and of the like. It's important that, if you look at this journey and this industry, that like I said, it's not monolithic. It's very much involved in collaboration, being open and flexible to work at this together.
I like the fact that you brought the people into that so strongly.
Absolutely.
Because obviously it's all about who is at the base of this, whose hands these tools are in. A lot of what you said was basically looking at the challenges of cost and change management within teams and across partnerships. Arvind, perhaps you can just sort of pick up on those points that Amit made and talk about the challenges from your point of view.
Yeah, I'd like to start actually with the aspect of that one of the biggest challenges is that every machine, every plant is very different. So that means operating conditions of machines or subsystems which has to be applied on they have a very high variance. So that means the AI models must be very adaptable. So they have to be applied on a specific machine. Plus, depending on the operation mode, you need to look at resources in terms of technical resources. The closer you deploy to the edge, of course, the more constrained you are. So that means you cannot simply throw AI models with billions of parameters on it if you want to be to deploy close to the edge. So coming back to what Amit said, and as a kind of summary, we are looking. One thing is we are engineering minimum viable models. That means we are really trying to find the simplest approach. We are pretty much look whether more complex models add more value over simple ones. But even more important, we really closely collaborate between data scientists and domain experts and engineers, because that's what we've learned. Very good results can only be achieved not only by throwing AI on something, but to fuse it with the engineering knowledge.
Yeah, and it's funny, Arvin and I were talking about this topic as well, and I think the comment you made around getting the domain experts involved with the data science folks is really important in the beginning, because you need to understand the machine or the process and how the day-to-day works, and who knows this? It's the people that work on the factory floor, and then who knows how to sort of interpret that information, build the models, contextualize that data and information. Well, it's the data scientists, and I think, Arvin, you were mentioning that it's really important you do that early on, but it's not like it needs to happen throughout the entire solution development, because the promise of AI and the topics that we're working on is to mitigate a lot of that, to spoon feed, if dare I say, some of these types of solutions as well.
Yeah. If I'm
Go
allowed
ahead.
to ask
Absolutely,
something?
that's why you're here.
Yeah. Especially for the leakage locator, this is a very good example. So what we did is we closely worked with the engineers in the Emerson labs, and we kind of simulated all, let's say, complexity factors which you typically see in the real-world application. And then we started with pilot customers in order to, in the end, finally have a prepackaged product where the end user only needs to press a button like calibrate and then apply, because end user doesn't want to care about AI models again.
That's interesting that you say that simplification for the end user, because we get back to the point about data and model training. Benjamin mentioned on the last panel that obviously AI is only as good as the data that it's going to be fed. And one of the things or the questions that companies often struggle with is this question of AI model training. How should a model typically be trained? And you're saying you're basically setting it up to be as simple as possible for the end users, but what prerequisites have to be in place? Perhaps I'll start with you, Arvin, this time.
Yes, well, I'm kind of a little bit of repeating myself, but for me it's a very important aspect. So end users shouldn't have to take care about how to train AI models. They should be relieved from that. I mean, if possible, they should use pre-trained models, like in generative AI. If you're using ChatGPT, for example, that's pre-trained on vast amounts of data.
But pre-trained, if I'm understanding correctly, it has to that training has to continue, right? Obviously, because do things have to be optimized, or?
Yeah, it's pretty much depending on the use cases.
Okay.
So the fascinating thing about large language models like ChatGPT is that they, by being pre-trained with a lot of data, they have a kind of a world knowledge, and you need sometimes you only need very tiny, specific small subsets to adapt them. But if you look at something like predictive maintenance, that's different, because again, every machine behaves different, and that's why models should be able to train, adapt, and optimize automatically on the specific environment they're working in.
Ahmed, what do you have to say about prerequisites for AI model training?
Yeah, absolutely. Just like Arvin, repeating myself a little bit, but I think data is at the center, right? And data quality becomes that much more important. And to Arvin's point, right? I mean, the GPTs of the world have kind of general knowledge, but if you look at a manufacturing plant, it is incredibly dynamic if you look at a specific machine or a production line. And there's a saying in the industry about you can be data rich but knowledge poor, and this is really important, especially when you're working on training and pre-training. The other piece is in terms of prerequisites is also around your technical infrastructure. I kind of foreshadowed that in my previous answer around compute. Are you going to do the inferencing and the workloads on premise, or are you going to bring that to the cloud where perhaps it's more cost effective and you have more compute power? It really depends on what application you're going after. So this is an important thing to consider. The third piece is, of course, all of this is possible if you have a pretty clear use case or a set of use cases. I keep going back to that because it's what sets the stage, if you will, around how you develop the specific model, the domain experts to pull in, the level of training that you have to do is going to be dependent on the use case. And after this talk, I encourage the audience obviously to see the leakage locator demo live and in action, so you can see how it's working. But I think, to Arvin's point, data and data quality is really important. But I also think that compute is also equally as important as well. And one of the things at Emerson that you'll see here at Hanover is where we're launching our next generation industrial PCs, which are capable to handle AI and ML workloads as well. So we understand that it's not just about developing the solutions and the use cases, obviously, as well, but it's also about having the infrastructure in place to deploy this on-prem for our customers as well. Some customers don't want their data in the cloud. They would like it on-premise as well.
That comes back to the question of security.
Absolutely.
Which obviously relates to technological infrastructure. Arvin, what further points would you have to add to that question of the required tech infrastructure?
Well, wow, this is a huge topic actually. So, so for once, if you deliver and deploy such types of applications, it may happen that you have to make very high frequent updates due to security issues.
Yep.
Which is something which is not easily solved. We have approaches for that, so that the customer is able to pull in new versions as on his demand, after being notified that there's a new security patch or something. So that's a real challenge, because I'd say the classical products are delivered once and then they run for ever.
Yep.
While in software, you have to do high frequent updates. So that's a real challenge regarding security.
So we've talked a lot about AI in automation, but where does generative AI come in? Because that's, of course, the next level, getting an awful lot of attention in recent weeks and months. Where do we currently stand in terms of the adoption of generative AI in the industrial setting?
Yeah, I mean, just like you look at the overall AI topic, it's pretty prominent and significant. Some examples I can give you that's widely used today is around programming and code development. So you have the topics of what we call AI co-pilots, which can help programmers be a little bit more productive, more efficient with their code that they're developing. A recent statistic that I was reading is that it can reduce development time by 20 to 50%. If you take another use case like for product managers or product marketing, we live and breathe by the voice of the customer and synthesizing all of this information, for example. Generative AI can be really good at distilling this information quickly for product managers to understand, let's say, what are the requirements, the market gaps, or the fit based off of the information that they receive. And you're also starting to see a space around Gen AI being used in more closed loop systems. And what I mean by that is, like, if you have a quality application, for example, and you have a defect, whether it's on a milk carton or a can or a bottle, for example, and it finds a defect on the label, you can apply Gen AI to basically send a work order to the maintenance person to say, hey, there seems to be a correction or a replacement of a part that needs to be made. And this is significant in terms of the productivity and the prescribing element that customers will get in terms of how useful Gen AI is. And those are just like 3 examples, but there's, I'm sure, hundreds and if not thousands of applications today that many people are testing with Gen AI.
Anything more to add there, Arvin?
Yeah, well, actually, I'm happy that you also
You're nodding.
managed not only managed productivity increase in development, but also product marketing.
Hey, I have to speak for my people sometimes.
Yeah, but certainly, I mean, software development, and not only on, I'd say, classical enterprise systems, but also on PLCs, is a huge area of application. There are figures that productivity is increased by 30 to 50%. I mean, you have to really carefully look at that, but there are other applications like legacy migration, monitoring, customer and sales support, IT service management, and actually general knowledge work is affected heavily by generative AI. But companies who want to apply Gen AI really have to consider that it's still fundamentally probabilistic.
Yep.
Well, basically, it's just saying giving that sequence of tokens, this sequence of tokens is the most probable one. Just to be sure, it's not really thinking, and you have to really be careful about that. And it's pretty much depending on the data it was trained on. And for me, especially its appearance of quality can be very deceptive. So because it looks so good, it can be very dangerous if you do not check the results.
Yeah. Yeah, I mean, I completely agree. And just to reiterate, right? I mean, when you use Gen AI tools, like any GPTs out there, right? They're two things. They're thorough, and they're plausible. And as a human, you can take that and say, "Wow, the quality of information is really good. It must be right."
Ready?
But
I'm done.
yeah, but this is dangerous. I think there's a really important element to this is that domain expertise still needs to be there. Because as I said, some of these prompts that you get in the feedback is thorough and plausible, but at the same time, you still need to, do your homework, if you will, to make sure that this is accurate and somewhat in the right direction, right?
Which comes back to the skills gap that you mentioned quite prominently, that a lot of companies, obviously in the manufacturing sector, are experiencing again and again, and increasingly as generative AI becomes something that needs to be mastered. Domain expertise, you've just mentioned. Can generative AI actually help to bridge that skills gap?
Yeah, I mean, so I would say that Gen AI is looking at areas, I would say, where you have jobs or at least tasks that will free us that are either dull or dirty or dangerous, right? And you have a variety of technologies, whether it's looking at Gen AI, but now you also have this new emerging topic, I would say for the past 6 months or so, called agentic AI. You'll hear a lot about it throughout the year as well. And then physical AI as well, where you've got robots that are now merging with artificial intelligence models as well. And it goes back to the comment that I made, is that, in terms of the skills gap, it will fill dull, dirty, dangerous jobs, but at the same time, you're also filling the need for, the lack of skill sets or people to bring on board with automation as well. So I think this is really a really important topic in terms of how the tool's being applied to solve issues around the skills gap there.
Do you have anything to say about the skills gap? And then we're going to open up to the floor here, because I think we've got quite a few people. I want to be sure we get all the questions in.
Sure.
Sorry.
Go ahead.
Pretty much agreeing with Amit. Just want to add a few thoughts. Well, if you look at skills or knowledge in companies, most of the other artifacts in like engineering, software development, maintenance are really grown and accumulated over time. So most of the companies have huge piles of documents which are very heavy to access for most of the users. And those artifacts are subject to rapid change, and they're very complex, distributed over different locations. So this combined with personal shortage and fluctuation of knowledge workers, this is really posing a challenge on many companies. And I'm pretty convinced that Gen AI can really help here, not only by generating due to its name, but also by extracting, collecting, summarizing, validating information based on best practices. So there are a lot of challenges, but to be very clear, Well, from my point of view, you can simply not avoid generative AI as a competitive advantage.
No, it's absolutely coming at us at the speed of sound, if not of light. Thank you very much for those insights so far, and I'm sure I haven't asked all of the necessary questions, so I'd like to open up to the floor to the various colleagues, and there's one right in front of us here.
Thank you. Tom from Minute Magazine. I have a few questions regarding what you talked about, air leaks. It's more about statistics. Do you now have statistics how AI improving versus human detection of air leaks so it becomes safer? And in following that, we know false alarms in production systems and such is a huge pain and often leads to less security because alarms are ignored because of there are too many of them. How can, or do you have statistics now that AI are helping to improve what's the important alarms are taken care of in a good way?
So if I understand the question, it's are there any let's say rules or statistics out there around the security of AI potentially impacting existing processes and creating potential issues? Yeah, absolutely right. I mean, I would say it's still a mix of both because I think you still need a human today at least to analyze, interpret that data, whether it's talking about them having decades of experience or at least having some domain knowledge to understand what's happening in their plant. I would say the area that you're looking at, or at least where AI is helping a lot in this world in this application is around trying to identify parts or components before they fail. Because I think one of the biggest issues today, especially around safety, is that you want to make sure that you're replacing either potentially bad parts or parts that are potentially going to fail in the next weeks or months before you have a catastrophic issue. So I think it's a mix of both still. I think it's definitely helping and improving production systems be more resilient, but I still think at the end of the day you need today at least a human or somebody behind it, of course, to interpret and analyze this information and to be fed specific kind of information to make more either of a data-driven decision or to have more context behind a process. I'm not sure if you wanted to add anything to this.
Nothing to add. Perfect answer.
Yeah, okay.
Thank you very much for that question. Are there other questions?
You explained that it will be good to think first about your vision, what you want with the AI or Gen AI, and I wondered if it doesn't make sense to use Gen AI in a brownfield environment, or is it only a good idea for somebody who's already just starting a new plant?
Do you want to take this?
Well, actually, I've one immediate idea on that. So if you're talking about brownfield, you certainly talk about PLCs, which are programmed in over years and decades sometimes, and you have a lot of legacy. So Gen AI can actually help to dig into that legacy and extract information from there, because sometimes it's not really accessible, and the experts who program those PLCs are retiring or something. So that's an application for the brownfield, I'd say.
Yeah.
Another instance of historical data, the importance of historical data. Any other questions from our audience?
So picking up on that, and I was wondering about your thoughts on, the entire engineering workflow of, let's say, a plant or an automation system and how that would change, right? Because you typically have your system integrator, they do programming, but with Gen AI, the whole profession and the whole cycle can change, right? So you can bring flexibility over the life cycle. And some thoughts on that?
Yeah, so that's I mean, absolutely there's definitely going to be impact on that life cycle, right? I mean, if you look at some application that I saw actually at the fair was how, to your comment around system integrators, what's happening now is that you could take an entire PID drawing, load it into a Gen AI model, and it's going to deconstruct all the parts and all the materials for you, and now you could prompt it. I think the thing to understand is that whether you're an engineer or you are somebody who's just getting into the field or you're someone with decades of experience, you are changing the way you're interacting with data with this topic, right? And of course, it's going to depend on how each perhaps skill or persona is going to, let's say, prompt or use the tool how they want. But at the end of the day, there will be a fundamental change. And I think that this change is about finally, for the past few years, we as humans are now figuring out how to really talk to data in a natural way. And then we're analyzing and interpreting these things. And then that PID example is one way to do it. Where going even further, once the Gen AI model deconstructs or looks at that PID model, you can now prompt it and ask, hey, well, this sensor X50, for example, what can I do in terms of adding another signal? Okay, well, the model will come back and give you a type of response. Now, you as an engineer or you as an expert need to sort of have the understanding that is this the right move? Do we test it? And maybe in the future, you can merge this topic with digital twin. You could test it in the digital world, run the resiliencies or the models or the operating window as to will it work or will it not work, and then push it down into the physical world. So I would say short answer is yes, it's going to impact this.
I'm sure you perceived the statement of I think it was the NVIDIA CIO who said that children shouldn't learn programming. I mean, this was received with a lot of critique also. But well, at least one can imagine that well, the need of engineering details will really go down. So some call it intention-based or vibe coding, for example. And that combined with simulation really shortens the feedback cycles.
Yep.
Thank you very much for that question. Do we have other questions here in our audience? Or are we getting to the point where we can wrap up? Thanks very much to Amit Patel and Arvind Agora as well for being
Absolutely.
here and walking us through this wonderfully complex world of AI in industrial automation. Thanks very much.